So let's see what is wrong with the foot IK system. And yeah, it kind of works already. So let me go a little bit more into details. And what you can do is if you go to show developer and click on bones, you will see the bones. So if I go into full screen mode, you will see that kind of the bones are not correct, like this one here. It should be here. I think that's the foot IK bone. And where we can also see it is if we go into, for example, this get up animation, and if you stop playing the animation, you will see here the IK bones, like this one here. That's the foot IK foot L bone, and that's the foot. Oh no, that's the hand IK. That's the. Oh, I'm always confused with those names. Hand IK bone, and here we have the IK hand R bone. So they are way off, and it looks weird. And I think I'm not 100% sure because I'm not very deep into this topic. And yeah, but so far I know the art tool which was used to make those animations from the creator of ALS constrain the bones, and somehow we are not in a lucky situation when we retarget the animations because the bones are not constrained anymore. I don't know if it's a feature or a bug, but let's see how we can fix it. So what we can do, that's the solution I was working a lot and struggling a lot to get it properly working. What we can do is if we create a structure as well and say blueprints st_tt constraint bone, and there we need a name and another name, and let me check how I name them, those variables. So oh yeah, the first one is the constraint bone, second one is the modified bone. Save them. So, and also here we do the same stuff like usual, st_tt constraint bones, and we create an array, of course. So here we say constraint bone constraint how I name the type constraint. Oh yeah, there's a typo, I think. So yeah, not a native speaker here, so maybe that's also wrong, but I don't care. Let's get it working at first. And here we say constraint bones. So, and we do the same. We create a data table, dt underscore, where is it, miscellaneous, dt. So constraint bones, okay, dt constraint bone. Save everything, and then we need, I think one row is enough at first. Let me see how I named it. Constraint bones, this one here. Yeah, that's a good name. That's a very good name. So create a new row. So constraint IK bones. Constrain all bones. Constrain all bones. Save them, and for that we need 17 bones. So let me paste them here. I will put a link in the description below that you don't have to type this and you can still add them. Oh, what I did wrong. Why is it? Oh, I know why. Yes. Sadly. Let me open Notepad++ quickly. So we need to rename those strings here. So if you have the hash in those, in those names, it will not work. So, oh, yeah, already replaced them. So the same for modified bone. I think here's also modified bone. Yeah, it seems to be I did it already. So copy this one and remove everything, paste again, and then it should hopefully work. Yes, it does. So basically we can say, for example, we will cover this virtual bone stuff later. So here we have the IK foot right bone, and we want to constrain it to the foot right bone. And then we will move with a blue utility as well this bone to this location. And yeah, hopefully get it working. So save everything, and then we can go into our hooks folder, and here we create a new one and say asset as well, asset action utility pp underscore constraint bone functions. So here we will do always the same, but it will be a different asset what we will get now. Anim sequence. Anim sequence, yes. Compile, save, and we add new function constraint bones from data table like usual, and duplicate this function constraint bones, and we will get the category names here as well, move them into those. This is the order we want to achieve, want to have. So in here we also do the following: add a new row data table member. Yes. Say data table. Compile, save. Oh, I am in the wrong function. No, I'm not. So here we call this function, and we also promote this to local variable L data table, and we set constraint bone, use the row here, the correct one, save everything, and then we move on. So here we do the same, split struct spin, and we want to find the row, get row, no, sorry, get row, get data table row, yes. So here we need as well a local variable, so here we say constraint bones. L constraint bones, and we will get all assets, get selected assets. We iterate all over them, so we need a for each loop. So we cast this to anim sequence, file. So now we get to the tricky part. So yeah, we also need here to promote this to a local variable L unim sequence. And here we want to do split struct pin again for each loop, because we want to constrain all bones. So, and then yeah, we need a new function. So that's a private one. Constraint bone. So, and that's a private one. We deselect column editor, and we want to say it's a private function. So, and for private function, I'm using the convention here that I say it's in the private section, so that I just know it's a private function. And in C++, I think we can do still here use the same approach. Private functions start with a small letter. Yeah, so call this function, of course, for every element here, and we say it needs also to have an input, and here we say constraint bone. This constraint bone, connect this one here, and we need the unim sequence here as well. So then we need to add the input here as well and say unim sequence. So can we, what did I wrong? Oh yes, unim sequence. Select this one here, compile. So yeah, very close, very close. Yeah, now it's a bit tricky. And what we can do is, as well, we promote the stuff to local variables here to avoid crossing wires. L constraint bone, and also the unim sequence, no, promote local variable L unim sequence. So, and then make it a little bit cleaner. It's okay for me. So compile, save, and now we need to call a lot of functions. So what we need to do is, if we say get num frames, and we need a for loop. So on the last index is the frame, the maximum number of frames. Move this here, zoom out a little bit, you can see stuff better. And yeah, so we need to get the pose basically, and this can be done with this function. Pose means here we get all local rotations and translations and so on for every bone, and for that we can use this function here, get pose at frame. I'm thinking currently, yeah, but I think it's fine for now. So, and if we have the pose, we can say get bone pose. Then we need the bone name. Here also split stop pin. And here we will need to get the constraint bone location basically. So target bone, you can also say, and we need to get it in world space. That's very important, world space. Because we need to translate this location. And then we say, yeah, that's a bit, yeah, it took quite some time to develop this, but you can do the following. So you can say set bone pose. And then you can just move the transform over here and say the modified bone. And you can also say in world space. So then you basically set the same location. So, and then, yeah, it's a bit weird because we just changed the pose, but you need to set the keyframes differently. There's a different function. We will see this in a few seconds. And sorry. And then we need to say pose, get bone pose again, because you can only set them in local space. So then we need to also do modified bone. And we need to call here or click on split stop pin as well. And yeah, let me copy this over this way quicker and explain this stuff. So what we need to do is here select this one, and we need the rotation converted to a quaternion. Then the location needs to be here, scale needs to be here, and we need all those local variables. So we click here on L rotations, yeah, create local variable, create local variable label, and also yeah. So you can do this very easily if you click here on the plus sign and then make them or convert them to arrays. So here you can click, for example, on this one here, and then you can here set an array. It will be a single value. For example, let us quickly do it. So here say L scales 1, and then we will see here the type, and here we search for vector, and then you will see it's a single value, and here you can click on array, and then you will get this one. And then let's remove it because I already have scale stuff here. Sequence node shortcut is press S and left click, then you get the sequence node, or right click and search for sequence. So, and what we need to do is, yeah, create arrays basically for all the positions, rotations, and scales. And if we have this, we can go back to the complete pin and do the following. Here we need to get all of them. You will see how it works immediately, and I will explain hopefully a little bit better, but I'm still working here. So we need those 3 arrays, and then that took me way too long to figure this out. I only was able to find this when I was working, or when I was reading the C++ code from the engine. Here you can say get the controller, get controller. It's a very special object. And then you can say set bone track keys, and this allows us, yeah, to set new rotations and locations and scale for every frame basically, and there we need to connect the right arrays to the right pins, and then we press Q and everything is aligned again properly. And here on the branch, or on the return value, we can introduce a branch node. and the branch node on false, so it basically failed to set the keys basically. And here we can raise an error message append, and we need to get the unsequence, get path name so that you get prop name, get path name, so where the asset is stored, the anim sequence basically. And here we say error failed to apply animation keys to this anim sequence here for the constraint bone. This one. And we also need more pins so that we get a proper error message. So here we convert them to strings. If we move the wires here, press Q again, so that everything is aligned like as expected and looks great. And I think we can also move this more to the right. Shift A, Shift A, and move this here to the right. So, and I think as the function here is very complex, I think we should make it a little bit more cleaner and check if I did everything correct. So we get the bound pose, we set the bound pose, and then we get it in local space and store them into arrays. Yes, that's how it should work. And here we can, I think, improve the wire a little bit. Move this down, way down. So I think this will look better. Yeah, we still have crossing wires here. We could, it's okay for me. For me, it's fine. I can read the code. Move this up a little bit, closer here. Also this one a little bit up. I think we can also align this one here. So yeah, you might get bored already, but then you see how I work with blueprints. In C++, that's way easier to code and to make it look good. So here, I think I can do the same. I don't like it, to be honest. I don't like how this looks like. Yeah, I think I moved this a little down, so this looks way better. Oh shit. Yeah, that's fine. Almost guys, almost. So let me move this a little bit down. This one here is fine, and this one a little bit up, and make the comment a little bit bigger. So yeah, that looks fine to me. And here, this is very important in my view. That's very complex stuff here. Here we say copy source, copy constraint bone transform. Oh, what happened now? No, that's very weird. Apply, that's a better comment. Apply constraint bone transform to the modified bone. So yeah, we basically use this world transform, set it in the pose, and then we get it again as local in local space. Compile, save, and here we set the keyframes back. So this is also very important. Here I will also introduce a command. Oh, I totally forgot the shortcut. You can press the C key on the keyboard. And here say apply all modified, apply all calculated, modified bone transforms. Local bone transforms. Yes, that's more correct in my view. And we let us move the command to the left. Okay, compile, save, and what we can do now is apply a filter and say animation sequence. Oh yeah, you can click on this icon here and click on animation and then select animation sequence. I already did it, that's why the filter is here, and I can click on animation sequence. Then I press Control A, select all animations and do a right click here and say scripted assets and say constraint. Oh, there's a typo. Let me fix this quickly. Constraint. Yeah, this function is very complex, but it works quite nice. So Control A again, right click, scripted asset action character tools, constraint bones. So it will take it some time because it's a lot of animations. 118. Why did it not work? Let me quickly check. Track with name none doesn't exist. Strange. What does that mean? Oh yeah. I'm so dumb. Yeah, we need to get the constraint bone local variable get and say split struct. Sure, this will definitely not work. Yes, this will not work. So everything is correct. Compile again, save, and also change something here. I don't like if you see it in the editor viewport. So we here set print to screen, uncheck this one, and move this up again. It's a little bit cleaner. There's also another error message in this one, which I might have forgot. Constraint bones, no. Oh yeah, one very important stuff who I also forgot. Sorry guys. We need to introduce another error message here. Yes. So here we say also print string, and we say append error the following data table. No, the data table did not provide the row. And you convert this to name, so that we get a proper error message here as well. I really like good error messages. I don't know if you would know what is wrong. If you see this error message, you can still improve it, but we want to get stuff working here. Right click, scripted assets and constrain the bones. So does it work? Yeah, it takes some time. We should see modified animations once this is done. So yeah, we have modified animations. And let me check maybe the pose. So as we see, they are properly constrained now. This is amazing. But the handgun bone is not constrained. So how to save the out of date packages? Oh, why? I don't want to wait. Let me quickly do it again, because I don't know if it is a bug in Unreal Engine or I probably forgot this bone. Let me check. So constraint bone. So where is the bone? Okay, these are the virtual bones. No, no. I think this bone is missing. Let me check. This one. Oh yeah, it is missing. So let me quickly introduce it. Sadly, I was not well prepared, to be honest. Sorry guys. So what we can do is, but you can see how I fix issues. That might be also very helpful for you if you are trying to find issues. I want to constrain the IK handgun bone to the IK hand right. So let's use this one here, hand R. Let me check if this works. So delete. Oh, it's not 17, it's 18 bones. And the order matters also. So at first we constrain the this is wrong. It's the modified bone is this one, and this is the constraint bone. So this should be correct. Let me see if this works. So where's the data table? Here's the data table. Can we delete this again? Paste, save, and we constrain again. Constrain, and we see an issue here now. IK hand L. IK hand L. So it's not correctly constrained. Football. Yes, as I said, the order matters a lot. You should not constrain those bones at the end. So this needs to be after the modified bone. So yeah, IK hand root, IK hand R. So it should be here. I want to improve this, but not for this session. We can use the bone indices basically to get the correct order, but this implementation does not yet order those for us. So where is the data table? Here's the data table. Delete them, paste. So because it works the following. So you constrain one bone, then you constrain the next bone, and if you constrain a parent bone after a child bone, then it will mess up everything, because the implementation does not take care about the order. So now we have properly constrained bones after a lot of time. So let me do this for the all animations and see if we then get better foot locations, or feet locations. So takes quite some time. Still waiting here. So save everything. Seems to work fine now. Let me check. So as we see, we have proper foot locations. They are so close to the ground. So close. It's perfect. And yeah, as you see, the IK bones matter a lot. They matter really a lot. But we will have a new issue. Look at this. So we constrained the IK handgun bone to the right hand. And yeah, this will totally mess up our overlay states. We will fix them in next session. So yeah, they are completely broken out. So look at the rifle. This is completely wrong. Yeah, or the box is also quite funny. See the box. So yeah, this is completely wrong. And we will fix this in the next session. This one got quite long already, but I hope you still learned something about the IK bonds in ALS and how they are used.